Hello again. I'm glad to see you again. And today we are going to talk about the sound energy. And we could see the previous unit, the previous lesson. Sound is also a source of energy. And I'm going to show you this summary that is on the plus zone. Remember, this is the basic concepts, and you can find them in your book in the plus zone, okay? And today we're going to see the sound energy. And the sound energy here says that can travel through the solids, through the liquids, and through the gas. So when we transmit a sound, or the sound energy can be transmitted through these surfaces. The first one, the solid, if we hit or to any surface, it transforms that heat into a sound. As well as when we hit the triangle, the musical triangle, and it says ping, 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 because sound can travel through the solids. Also, the sound can travel through the liquids. Even inside the water, inside any liquid, we can transmit some liquids. Here on your book, you've got some animals. These are the dolphins. Dolphins are quite special because they've got echolocation. The echolocation is the way they have for knowing where they are or where to go. They transmit some sounds through the water, and that sounds when they get back to the ears, thanks to that they know where they are, where to go, how to move, and that is the echolocation. So it's the same thing that we use for the radars in the planes or in the boats. And also it can be transmitted, the sound, through the gas. The air is a gas. And I'm going to draw you something here, because I think this is quite easier if we draw it. Imagine that this is an ear. You know that I'm not very good at drawing. Imagine that this is an ear, and when someone says something, that sound, this is the sound, is transmitted through the air. I'm talking, and I transmit that sound. Through the air. You cannot see, but here in between me and the microphone, there is air, and the air is the channel. So the sound is transmitted through the air, and it goes inside our ear. Then inside our ear there are some bones and there are some nerves, and that information is processed and it goes through the brain, and the brain interprets what is heard. And also, he said that the sound can travel when there is no air. So in the space we cannot transmit the air. And also when we've got a window, for instance, a window, sometimes the window has one layer, and in between there is a space that is called the vacuum. That is made in order to reduce as much as possible the sound. That's what happened with the windows. If there is a good window, they got one layer and a space in between them, and that makes that the other sound, the other noise, can be heard by us. And the sound is also a form of energy. And it allows us to hear things because it travels in waves, through the air. And then that vibrations are the ones that go inside our ears. And there is something that we have to take into account: the noise pollution. Noise pollution is caused by the noise. The lot of a higher amount of sound can be bad for our body, can harm our ears, and that's really important. That's why we have to try to reduce as much as possible some harmful and very high noises on sounds. Okay, it is not good being next to a very loud speaker or working with machines like this one. And when you have to work with them, you have to use some ear protections. That's why some people who is working with machines or transportation, they use some protection in the ears. Okay, like we may do not see it, but they use some ear protections. Okay, and the properties. Now we are going to see the properties. Sound has three properties: the pitch, the intensity, and the timbre. Okay, the pitch is how high or loud is a sound. Well, this could be explained better by Angela, not me, because I'm really bad at music, but I'm going to try to explain it as better as I can. Okay, so the pitch can be high or low. If you can see here, this is a violin. Happens the same with a guitar. Violins and guitar has got strings. These are the strings. Okay, these are the strings, and the thinner they are, the higher is the sound, and the thicker they are, the lower is the sound. Okay, so if you want to make a higher note, a higher noise, a higher sound, sorry, you have to use the thinner strings. And if you have to make a lower sound, you have to use the thicker ones. Okay, the thicker. The intensity is how loud is the music. Okay, how loud or how quiet is the sound. And the harder you hit something, imagine that you got a drum, the harder, boom, boom. If you hit it harder, the louder sound you're going to produce. If you hit with a very low intensity, the sound is not going to be loud. It's going to be quiet. Okay, the quieter is going to be. And the timbre is the tone or the quality of the sound. Okay, is the quality of the sound the musical instrument produces in this case. Okay, and I think this is more or less all the things that you should know about the sound energy. Remember, if you have any doubt, you can write any comment on the video. You can ask me anything on the class dojo, and I will try to answer your questions. Okay, bye.